So, friends, there was a time soon after Big Bang when there was nothing in the universe. There was absolutely zero material, and you know that you need matter. You know, things like atoms, things like some sort of nuclear science going on in the universe to create the next level stuff, which is light. And light is the thing which actually tells us what is going on around in this space around us, and therefore light is very important. However, when the Big Bang happened, there was no matter itself, so there was no question of light. All right, so the bang, if it happened, probably happened in complete darkness. We say that it was a big explosion of energy which became sort of imbalanced on a particular point. However, that explosion was without a sound, without any light. It was only after 300,000 years later the temperature of the universe came down significantly, and when the temperature reduced to certain level below what it was earlier, the matter started to form. And the first matter that was formed was just a simple proton. And of course, when the proton is taking shape, the electrons were also created, and hence we got the first material in this universe, which is hydrogen gas, because one proton and one electron. Highly reactive hydrogen gas, because it is wanting one more atom to become stable, and one more electron, I beg your pardon, to become stable. And since there was nothing else, it was all hydrogen. The quickly gravity started playing its role, and the whole material which was created, new material was created, and it formed huge stars. Really big stars were created. These stars were of humongous size. Today, if you look around in our universe, we actually see very large stars, many times bigger than sun, but they are not very big as compared to the first generation star, which we call them P3. P3 stars, which are also known as first generation stars, the first stars to be formed in our universe. These stars were huge. These stars were 200 times at least the mass of sun, at least 200 times the mass of sun. So huge star. They burn very brightly. Estimate is that they would have actually finished their life in just 200 million years. Compare that with sun. Sun has a life of 10 billion years. So in just 200 million years, these large stars consume their hydrogen in the core, and then exploded with huge supernovas. There were huge supernovas, and you know that, friends, the star is a element creation factory. So since there was nothing else except hydrogen, these stars actually created helium in the core, also lighter elements like beryllium, lithium, oxygen, carbon, maybe. So lot of material was created, but not the heavy metals. So oxygen was created, which is very interesting. When the star exploded, they actually return the excess hydrogen back into the space, and since in that explosion oxygen and other things were also created, including helium, the oxygen immediately combined with hydrogen, so the water was formed. So if you look at the early history of universe, the water was one of the early molecule which was created openly in the universe itself. Why water? Because oxygen was created freshly, and hydrogen was readily available. The size of the universe was also not as big as it is today, and therefore things were very close by. Oxygen immediately combined with hydrogen to create water, and so water is probably very ancient that we have on Earth. We keep saying that from where this water came. Probably all the water that we see around in space, which is mostly in the frozen state, was created soon after the first generation stars exploded into supernova, and then the second generation stars started to form. Remember, there were no galaxies at that point in time. These stars were huge. They were made of hydrogen, and they created lighter elements, and when they exploded, they created water. they also created these lighter elements, and they returned the excess hydrogen back to universe so that the second generation stars can form. Now, when the second generation stars were formed, there were no galaxies still, absolutely no galaxies. And the simple belief is that the galaxies will have to form in order to provide base for building stars, planets, etc. But the latest hypothesis is that this may not be the case. There was all the material available when the second generation stars were forming. When the second generation stars were forming, there were heavier elements. The stars immediately created a protoplanetary disk, and the core of the protoplanetary disk collapsed into forming a large star, right? So the large stars were created, and around the stars there was a reduction of temperature, and because the temperature reduced, the lumps on the inside the other material which was left over when the star was formed, this stuff actually collapsed into planets very quickly. All right. So without the galaxies being created at that point in time, very early, the scientists now believe that the solar systems would have formed, and some of these solar systems would have been habitable. Some of these solar systems where there was water, because there was a lot of water, all the material like carbon, etc., silicon, would have created a heavy structure, heavy planet, and there was a star which is second generation star, um, and which is giving energy, life, etc. So there is no reason why this planet could not harbor life. So scientists are now saying that even without galaxies, there was a chance that the planets would have formed very early in our universe, which would have given rise to very early civilizations. And this is one thing which is affecting our all thought process. Now, if we want to identify these planets which were formed even before the galaxies were formed, which could have harbored advanced civilizations, I think we should look at the extinct planets around the very old stars. So if there are old planets around very old stars or around white dwarf, that could be good candidate to ascertain whether there were planets like that. There were planets as old as the universe or much older than the galaxies. Galaxies came later because all this material, all these different solar systems, when they were formed, they actually created the gravity, and then gravity played its role. There was dark matter also, so all the material actually naturally start rotating around the dark matter lumps, and that actually gave rise to the galaxy. So the whole theory is that planets came before the galaxies. There could be a chance where civilization would have evolved on a habitable planet somewhere in the universe. They would have actually advanced to very high technological advancement levels, and they would have actually spread across the universe, and they would also have gone extinct on that planet. So I think the target should be to look at those planets today and see if we can find the evidence of such civilization. And the galaxy is basically formed much later, and therefore this is something which is very remarkable, and also some points that we should think about how the universe started. I mean, we know the basics, like there was a big bang, the material was formed, light was formed, and then first generation star came and went, and then after that second generation came, and now the sun is a third generation star. So we know that after all these stages, there is so many heavy material which are already available, up to uranium. But there was a time when there was very little metals available, and in that era, if there was a civilization, they would have looked totally different. So I will end my video with a question: what is that you feel would have happened at in the early part of universe, during the early lifespan of the universe? Is that we evolved very early in the universe, and then we actually went through iteration to iteration, and eventually now we are known as humans. Or we completely evolved on Earth on a third generation star system, and here we are questioning, the life producing planets, habitable planets today. All right, friends. So thanks for watching, and I will see you again in the next one.